Well, good morning, Minneapolis. Good morning, Minneapolis. I'm really delighted to be here and join you this morning. We have a star-studded, no-kidding panel that I'm just delighted to be able to talk with a little bit this morning. We're going to have what I call a discussion, especially amongst and between the panelists. I have encouraged them, if somebody says something that maybe the other person does not quite agree with, that's okay. Call them out on it. Now, we'll be kind, courteous, but we don't want to literally agree with every word that is said back and forth, because that's like boring. So, my name is David Batz. I'm the Managing Director of Cyber and Infrastructure Security at Edison Electric Institute. Been with the Institute for a little over 13 years. Previously, I was with an electric company in the beautiful Midwest, just south and east of here, for about 20 years. So these are my people. So it's really great to be with you here today. And welcome. Really glad you could make it. So our panelists, I'm just going to briefly introduce the panelists who are the actual stars of the show. So Ms. Emily Allen, Vice President, North American Enterprise Markets. Emily is responsible for the go-to-market strategy, sales, deployment, and support of major enterprise customers. Emily has held engineering, project management, sales, and operations through her 20-year career with Motorola in both government and enterprise markets. Emily serves on the board of directors for National Association of Women Law Enforcement Executives and the Detroit Public Safety Foundation. Thank you, Emily. Mr. Ken Kaminski. Ken is the Director of Security for Private Networks for Ericsson Market North America and is responsible for the cybersecurity of mission-critical mobile networks, including Department of Defense, various military and public safety, large enterprise, and electric power utilities that require expertise in multiple security domains across RAN networks, transport, and core digital service areas. He defines and analyzes cybersecurity solutions for the next generation mission-critical communication systems based on 5G and 4G technology. Also works with government agencies, standard bodies, and industry committees. Welcome. Mr. Joel Silberberg is the VP of Business Development at OneLayer. Joel has a long, successful career working across multiple disciplines in the network security area. Joel has worked closely with the NSA and the Air Force to deliver solutions to secure their most trusted communication networks. Prior to OneLayer, Joel spent 5 years helping to pioneer the OT security markets, providing asset management and zero trust solutions to hospitals, defense manufacturers, water utilities, and oil and gas companies. We're going to talk a lot about zero trust this morning. In fact, pretty much that is our topic. Now, last and certainly not least, Mr. Jeff Tufts, Global Utility Practice Leader for Cisco. Jeff has more than 15 years advising national infrastructure security operators on how to best leverage commercially available technology to effectively support OT operations in a secure, highly available, and fiscally responsible way, which utilities are definitely interested in. Fiscal responsibility. Currently, Jeff is the Global Utilities Director for Cisco Systems and is a doctoral candidate in cybersecurity at Georgia Tech. Go Bulldogs, is that? No? Ooh.
So, it's funny. I think that was written years ago, and after about a semester, I gave that up. So you don't have to call me doctor.
Okay, good to know. So, just a few brief opening remarks. Fundamentally, the utility system as we know it, when we think about electric companies and operations, is going to change more over the next 3, 5, and 10 years than it has changed at all in the last 100. It is changing in so many ways. New energy resources, distributed energy resources, communications infrastructure, and the connectivity to put all of those things together. At the same time that is happening, we are also facing, no kidding, both physical security issues and cybersecurity issues. The FBI released a report in late last year, I think, that indicated domestic violent extremist attacks had gone up by nearly 400% over the last 10 years. I don't have to tell you, cybersecurity attacks are changing and growing and new and different every day. So we're facing this increasing landscape. We're looking at a really interesting overlay of, I'll say, some of the classic cybersecurity issues, the good old principles, confidentiality, integrity, and availability, overlaid with new communication, both requirements and options for customers. When we think about zero trust approaches, as you know, you can't just run down to, nor would you want to, run down to Best Buy and buy yourself a zero trust solution and just blam that in. That's really not how it works. It's really more of a philosophy and an approach. And living in a hybrid world where some of the system is using zero trust and other elements of a system are not using zero trust is a reality that everybody is going to have the opportunity to work to consider for a long time. So let us jump into it. Emily, you're up first. Emily, can you tell me how should or could utilities approach physical security differently in a zero trust environment, and how do they do so leveraging investment in private LTE? If you can talk a little bit about some of the technical advances of video security and access control that blend into this discussion.
So it's certainly different from in years past, right? Everyone, it doesn't matter what industry you're in, everyone relies on video for a lot of things these days, right? You see it in the news, you see video helped us here, video helped us here. And I think you need to kind of look at it three ways, right? You invest in technology to help protect your assets. So how do you maximize for operational efficiency of just what you're trying to achieve? Next, how do you leverage that investment with the other platforms that you're investing in, the other systems, to go above and beyond to get a bigger return on that investment? But then most importantly, what you really need to start considering now is how do you protect those assets? How do you protect them in the zero trust world? So specifically from advancements in technology, when you think of, you go in, I go into Target and I shop and the camera's looking at me when I'm doing the self-checkout, right? But, we think a lot of cameras that are securing, a substation or allowing access into a facility that's remote. A lot of the advancements in technology have been around analytics and AI that help the cameras be self-learning and learn, hey, what's unique about this location? What is it common to see 3 cars pull up to this location? Is it common to see a lot of people on site at 1 in the morning? The technology has evolved to kind of learn situationally, what's expected, and it can make decisions and send information back to other systems. It can be managed through the cloud, it can be managed on-prem, but you have a more analytical approach to how you're managing your response, right? So in addition to that, you can have the analytics send workflows through communication, right? So when you're analyzing the situation, and then you determine what does the response need to be, right? There's someone on site. Do I need to radio someone? Do I need to send someone? So I think that's a lot of the advancements that come with the actual, the physical security equipment and the software. It can do a lot for you, but how do you keep that safe, right? How do you make sure, you've invested a lot in this technology and it's doing a lot for you? How do you make sure you're maintaining cyber patches? How do you make sure you're getting the latest software patches to it, right? Because the more you distribute, the new technology, the more vulnerable it becomes to, the bad actors out there. And I think that's what some of my colleagues here are going to talk about, is how to more protect, multi-layer systems that we're relying on. Physical security can evolve from, the basic guard to access control to video to a very elaborate video system. How do you take that data that you're collecting and that's learning about your sites and telling you what's going on about there and drive it into actionable outcomes and share that, whether it's through, workflow applications, whether it's through communications in response to an event. I think those are a lot of questions that need to be asked, and they're probably questions that span over multiple organizations within an enterprise.
I just want to add to that just for a second, to maybe take one step back and lay the framework a bit, because it's in the title. So what is Zero Trust? Maybe we just take a step back for folks that aren't focused on security or the business folks that might be in the room, because I think it really ties in well with what you were just saying. So if you think of historical security, I suppose maybe in a non-technical sense, right? So historical cybersecurity and physical security looked a lot like build a castle wall, right? And you'd have a bridge over a moat, and that was sort of both from the physical security standpoint and the cybersecurity standpoint. That was sort of the pre-Zero Trust, and then Zero Trust became somewhat of a marketing term for a while, perhaps partly to blame is Cisco here. But over time, over the past couple of years, that arguably marketing term started to evolve into something that felt like a standard and started to gain a lot more traction. Regulators, particularly in the federal space, started moving in towards this term, and so it started to take on a little bit more concrete definition. But in a very general sense, and this is why it really dovetails into what you were just saying, is that if we go back to the castle analogy, what was just the castle wall, the moat, and the drawbridge now becomes sentries that are in the castle. So monitoring for folks that have clearly climbed the castle wall, checking for papers to make sure they belong there, and then figuring out what to do once you find someone that's breached the castle wall. So instead of just looking, hey, I've built a castle, walk away. So in sort of cyber standpoint, and I don't know the right terms in physical security, so we authenticate ourselves, the people, the applications, and the flows. And then at that point, once you've authenticated, what used to be is, hey, go at it. You've been authenticated, do what you need to do. And now it's a constant verification. So trust is now temporary instead of before. Trust was permanent once you've passed through the gate of authentication. And so to your point about, I'm sort of making this up in the physical security, where like I've been authenticated physically to enter the sub, but from a video surveillance standpoint, should that person be over there versus over there, I can imagine.
And how do you manage that?
Yeah.
Right? How do you say, do you have to call someone and say, hey, that person's in a spot they shouldn't be? Or do you have the technology that shuts off the
And
access?
it's the same thing on the cyber side. Should that user, I've authenticated the user to do one thing and one thing only. That's the first step. Now I can continuously verify, they are doing something else that they weren't authenticated for. And then finally, how do I stop that actor, that flow, whatever? I wanted to go back since it was in the title, and it's a somewhat of evolving concept.
Jeff, I really appreciate that. And to your point, back in the old days, a big wall and a drawbridge was sufficient. And today it is not sufficient. Today, for a lot of reasons, you can end up with challenges inside of your network. And that's what Zero Trust is fundamentally about, is how do you, as an organization, respond to threats, not just out there in the evil internet, and the internet is evil, to be sure, but now, what do you do when the problem is inside your own house? And it's not sufficient to say, well, we just trust, if it's our house, we just trust everything. It's no longer enough. And so, Ken, as it relates to a private LTE network, how do you incorporate some of these issues with wrapping in some of the classic needs of a utility network solutions, and how do you prioritize which sorts of approaches are most important?
Yeah, so it's interesting. In terms of what your cyber architects actually have to navigate when they're designing these networks, there's actually 3 models, of which zero trust is one. So you have your traditional NERC SIP model, which is based around the concept of an electronic security perimeter. It's really the castle and moat kind of idea that Jeff was alluding to. So that goes back a little ways, but NERC SIP is really built around that idea. You have a perimeter between IT and OT, and all of your defenses are really right there. Then in the cellular world, there are standards. For the LTE world, it's TS 33401, and 501 is the 5G side. In the LTE world, that was also built around the concept of castle and moat. So it has very defined security areas where everything is dictated. And then zero trust comes along and basically takes that model away and says, hey, you got to understand now you have tanks inside your perimeter. And you've got to look at your network as compromised from the beginning. And like Jeff was saying, every single transaction has to be actually authenticated and authorized at the device level, the user level, and the application level. And in the cellular world, it's the 5G system that's bringing in all of the zero trust stuff. Now, that's okay, actually, because there's a tremendous amount of security that's built into the LTE side of the equation. For instance, the RAN side of the radio access network, that was designed as critical infrastructure from the beginning with the understanding that this stuff sits in isolated areas where it's not manned, there's no one out there. So there's a tremendous amount of what are called baseline security controls that are built into that by the standards with the assumption that no one's out there. So there's quite a bit of those that are built into it there in terms of that. But the cyber architects actually have to really manage those 3 models and bring them all together as we're moving towards this zero trust world. And it's coming. There's a dictate that's coming eventually. The Biden administration, with the Office of the National Cyber Director, they had a strategy document that came out in March where they basically said, hey, look, our industry best practices are not working. And one way or another, we either have to formalize those or regulate them. And telecom is considered critical infrastructure. The U.S. government has mandated all of their agencies to move to zero trust. So it's just really a matter of time before we have to bring all of this stuff together, you know, on the utility and the private network side.
Thanks, Ken, and that's a really great lead-in for Joel, who wins the next question of can utilities, or maybe better stated, how can utilities extend some of the classic things that are well known and well understood, the Purdue model, into thinking about zero trust architecture principles and maintaining practices like visibility, security monitoring, and breach detection to their new private cellular networks?
So thanks. So Purdue model is well-known framework that manufacturing companies, I guess lots of organizations use to segment their network. So everything's a layer, and things sit at different layers in the Purdue model, and you grant different access under zero trust for what those different layers are allowed to do. So you verify who they are, you put them in a layer, and then you create rules and policies for how those devices can behave to to do that model effectively, it all starts with knowing what assets you have. So it's very, very device-centric, and it leads to really drilling down on you can't secure it if you don't know it. So it requires companies and organizations to start to put in really strong asset management type solutions to really inventory and understand exactly what's in their network. Because if you're going to grant access, you're going to verify it and grant access, you better well know what you have, because otherwise you're blind. So sort of the first step in Purdue and the first step in, from my thinking, in implementing Zero Trust starts at the device level. Know your assets. And it's an interesting paradigm when you start thinking about 5G, LTE, and cellular around what's an asset. And is that asset a SIM card that you've provisioned and you understand in your network, or is that asset an actual device? And is it the device that you need to track, not the SIM card? And it starts to add very interesting questions about how you bring a Zero Trust model into the LTE world, because you don't, without a clear picture of the assets, you can't verify to trust. So I think that's the first question in this model. We can start to go through: how do you authenticate? How do you write policies? How do you react when you detect things? But I think it fundamentally starts with understanding the assets.
Okay, thanks for that.
I just want to riff off a couple of the last points there and just pull the plug, because I'll just talk forever. So I think that, and I think this might have been leading into your next question, is, you know, the Zero Trust model, all having the centuries and everything that we just talked about, that's pretty easy to do when you're in the enterprise. So if you're a financial services industry, you're going to deploy every aspect of Zero Trust and keep your crown jewels as safe as possible. One of the challenges that we come in that sort of intersects directly with the meeting that we're here for is, how do you do that with a cap bank controller? You're not going to put a rack of gear on a utility pole, right? And so that starts to be, you know, we need to do this. Well, we want to do it. It's the right thing to do. And in some cases, we need to do it, particularly if, you know, as we get closer to where you deliver power to federal institutions, military, and so forth. CMMC is going to start governing the reliability standard of critical assets, whether it's delivering power, delivering water, whatever the case may be. So there's things that are driving us that have never driven us before, like NERC SIP has and so forth. But the challenge that I see, the sort of unmet, we haven't really codified how to do this, is how to do something that looks like Zero Trust to 100,000 endpoints that are on a utility pole. So there needs to start being that value engineering sort of mix to say, what can we do, what's right out there? You know, to your point, okay, we can identify the asset, we can identify, you know, in our case, the router, you know, someone can identify the cap bank controller, the firmware on those things. But then the next level down is, well, we need to identify the flows. And what are the application flows? What did that application flow look like in steady state? What does it look like in storm response? The amount of technology that's required to do that at the edge starts to exceed the complexity and cost that anybody wants to do at a scale that's tens of thousands of units. And so, you know, we really understand how to do it in a data center and those types of things, but how do we do this in a distributed model? And that's where some innovation is coming from. That's where, you know, it takes a lot of different companies to come together and do that. That's, from my perspective, a big challenge right now to figure out how to do that. Like I think we understood it when we weren't doing Zero Trust. It was, the edge is untrusted. We'll go through sort of an inspection process before you get into the control center and keep it trusted. That's no longer sufficient, but I don't know that we've, as an industry, figured out what the right thing to do is to kind of extend that Zero Trust model out to the very edge.
There's also there's an interesting difference in the cellular mobile network operator world and in the utility space as to how you look at devices. And that's fundamentally different between the two. So if I'm a mobile network operator, you know, like Verizon or T-Mobile or AT&T, the only thing I actually care about is that SIM card or the eSIM, you know, that's in there. I don't really care about the device and what's running on it or whatever, because I'm really providing a service there in terms of communication. In the utility space, this is fundamentally different. You're an enterprise, and you need technologies like you have on your IT side, where when you connect in your office, it knows that, okay, your network is saying, hey, I know that's my device, this belongs to me, my utility. I know the person that's on it, and I have security controls that are on that particular device in order to do things like anti-malware and whatnot. So you have to have those controls in the utility environment, whereas in the cellular environment, you do not. So this is something, that I highly recommend you think about, as you're deploying these networks. You've got to have, some technology that's looking at that, and that technology integrates well into, in particular, the core of the vendor that you're deploying there for the cellular core. So that's a big difference between mobile networks and utilities, but a very important one and something to think about.
And just continuing that thought, being relatively new to the cellular world, but coming from IT security and being in security for a long time, you've got to figure out how to do that and at the same time bridge it into the IT world so you can manage it and you can scale it. Companies have spent, even utilities have spent a lot of money putting in security mechanisms to secure their IT infrastructure. And now you're adding a cellular network, and you want to be able to take the same controls that you've put in your IT environment and use those same controls to manage the cellular network. So, looking at them like an IT asset, almost thinking about it like it's a financial institution, and you want to write the same rules, the same policies, you want to use the same SOC, the same NOC, you want to plumb the cellular network into your overall IT cyber infrastructure. And I think it's something that wasn't addressed in the early networks that came out. There was so much emphasis on just making sure that the cellular network itself was so secure that there wasn't as much thought about, hey, how are we really going to scale this? How are we going to manage it? How do we bring it into the same policies and procedures that are used in the traditional IT world to help protect the networks?
Yeah, and I think this goes back to what Bobby said, and I think what Jenny said earlier is we collectively want to put the financial system or a DoD level of zero trust everywhere. We can't for the reasons that we just mentioned, but getting feedback from the industry of what aspects do you want out there? What makes the most sense? Is it just flow control, flow monitoring? So whatever the technical pieces are, we continue to try to, the vendor community continues to try to innovate and meet the utilities where they are and where they want to be. But the more we hear from utilities in sessions like this or environments like this, the better we can innovate in the direction you want us to innovate. So I want to circle back to something you had said earlier, which I think is just spot on. So all things cybersecurity, like when you do red team exercises and so forth, it's like water, right? Water goes wherever it can. It goes to the path of least resistance. And so if we're in a red team exercise, I'm not going to try to go after the LTE protocol. Those closed systems are very secure relative to other things. It's always relative, right? And so you're always going to look for where's the easiest path forward. And so I suppose if you're MGM, you just call you call the front desk and ask for a password. But in this case, you're not looking at closed systems like the 4G, 5G protocols and systems. Like if you get a LTE system delivered by Nokia and Ericsson, that's going to be pretty secure. That's pretty well thought out. The weak points tend to be the system interconnects, right? Because that architecture is from the SIM to the packet core. Kind of making that up. That seems right. That's not my world. But it normally doesn't exist all the way to the endpoint. It doesn't exist from the endpoint to what the recloser controller is. So that's a subsystem interconnect that's going to be a weak point. Far weaker than a 5G standard that's been ratified and really, so if I'm looking for a weak point, I'm going to go after the packet core server. It's a whole lot easier to take down a packet core server, to get to the packet core server, than to get between the air interface and the RAN, for example, right? So that's sort of starts to illustrate the notion of zero trust is don't go after the closed systems, go after the system interconnects. Tends to be, when you do a red team exercise, that tends to be the initial spot you go after.
Or go after the devices, like
Yeah.
a lot of
Yep.
100%.
go back to cameras. They're
Yeah.
not Motorola cameras, but
And-
there are the Best Buy cameras that
Thanks for that.
that they become the weak points.
Yeah, I think we were saying they're not Motorola cameras that are out. It's if you go to Best Buy and get a camera, because there's, and we've seen this, right? There's two use cases of this, that you can go to cameras that don't have secure development life cycle, that don't have secure life supply chain, and you can resource the networking and compute capabilities of a non-hardened, non-security hardened camera to do an internal denial of service.
Absolutely.
That's happened a couple times, right?
And I think that kind of weaves into, I think, another question you're getting ready to ask is when you look at some of these end devices, having trust in the device and how they were designed and how they were made and what their purpose is, I think is an important consideration in research, right? Even from a physical security device perspective, there's a lot of industry chatter around, where they're sourced from, what their purpose is, are they spying on me, right? You hear with some of the apps that folks use on their phones, same concerns, right? So the diligence is needed to dig down deep into their, where is it made? Where is it being assembled? Where are the components coming from? And what kind of security and procedures are being put around that process too? But even going back to when you were talking at the edge, and I know you were all talking more in the zero trust and some of the cybersecurity pieces of it, but when you even think about physical security and what you can look at the edge and the edge analytics that can pull in just what you need, right? So maybe there's, for physical security, if it's a video feed, you don't need it constantly streaming back, constantly open for, someone to intercept or someone to get into. It can be situational and when there's a need for that information to flow through. So, I kind of tend to think that some of the advances at the edge give us more flexibility and scalability to control some of the other security pieces of those vulnerable products.
That's a perfect point. And so from our standpoint, when we're doing research, we're copying, I think physical security came up with the paradigm first in the sense that report by exception.
Mm-hmm.
Right? Because physical security is so heavy on networks and before private networks were really prevalent, you had to develop the analytics to report by exception. And as we're trying to develop new innovations at the edge that are security related, a lot of that requires, you're not going to do the processing at the edge. You're going to do some light processing, and so we're developing, and other vendors are developing the same idea from cybersecurity. If you're on a pole top, security processing at the edge, report by exception. So we're trying to copulate. Wrong word. Let's just take a moment, remember what I just said. We're trying to copy that paradigm that was developed almost 10 years ago when everything was trying to go off 3G and, you're having physical security in a parking lot. So same exact thing. That level of and now that AI is getting a little bit more sophisticated, particularly in the security side from a networking standpoint, we're trying to copy that model spot on.
On the device side, too, you'll want to, kind of in the older paradigm, we really didn't think too much about, when we were thinking about IoT devices, security features that are built into those devices. And in this zero trust world now, as we're buying all these different types of IoT devices that we're connecting to the network, these security features are becoming more and more important, in particular in a zero trust world. So CTIA has IoT security standards and that define, different levels of those particular standards. So as you guys are buying these devices that you're popping all out there on this private LTE network, you'll definitely want to think about those types of things. Does it have TLS encryption? Is it authenticating properly to its application that's sitting within the data center? Are all those security controls, on that particular device? In the past, this just wasn't important to us. In this world that we're in now, it's very important to us, and that's included in, the specs and the standards that you're looking at with these different device vendors.
And I was going to piggyback. I mean, when I think of zero trust, also sort of the logical piece that comes to my mind is segmentation and microsegmentation. This concept of we need to know what kind of devices we have, and then we want to create policies that allow devices to do the things that you're allowed to do. In the physical world, you're allowed to go over there, but you're not allowed to go over there, and you put up gates and controls. Same thing, same idea with segmentation. And it can start to get really overwhelming. There's so much data. If you're verifying everything, if you're checking every application, it can become a real bottleneck, and the last thing everybody needs is just more raw data flowing. So another, at least in my mind, when you start thinking about zero trust, the concept of policy and segmentation, and how do you enforce zero trust, and how do you make that a manageable task is another thing that's just not thought about. And maybe it's thought about in a static world where you do it at the beginning and you create very static groups. And that's great when a network is X, but then when the network grows by 10X, these static things don't work. We need to figure out how to do automation and auto discovery and auto-populate groups that can follow rules and policies. So zero trust starts, once we get the baseline of we've identified the assets, we need to start thinking about how do we execute zero trust.
So I asked Bobby if I could have a 4-hour segment to have this discussion, and she denied my request. She said, I do not trust you to do that. So what we're going to move into is sort of some final thoughts, and don't sleep on me because I'm going to flip the order around a little bit because we all need to stay on our toes. What I'd like to hear is some of your final thoughts, and as you share those thoughts, one of my areas of interest is sometimes we point at other organizations and say, oh, they have centers of excellence. We would never say that about electric utilities. However, a lot of folks in different disciplines are now having to interact and integrate with new technologies and new approaches, things like private LTE and et cetera. As you give some closing thoughts here, can you share a little bit about tools or methods or approaches to provide new information to perhaps classic security folks about how to use and how to leverage private LTE networks and some of the concepts that we've been talking about today. So as part of your closing remarks, and we'll start with Emily. So how to help people who are not used to having to fret about communications and things like 5G and private communications, and also keep it secure. How to bridge some of that gap.
Look, I think at the end of the day, no matter which piece of that pie they touch, safety and security is paramount, right? So I think sometimes it's sitting down, and maybe it's multiple stakeholders from multiple technology, experts to say, how does this elevate security, right? How does this make each asset more secure? And where are the overlaps that they can help each other? Where does, video at the edge help drive, better communication, more efficiently? And how do you translate that? Because after safety and security, bottom line comes into play, right? So how do some of these operational efficiencies and risk management around, the cybersecurity, how does that translate into an ROI that they can, all kind of get on board together with?
Thank you. Ken?
Yeah, it's interesting. I think, when in describing like a private LTE network to like an enterprise, I like to just kind of, put it in the terms that they understand it. So you've got a radio network that's just converting everything into standard IP packets, the standard protocols that you guys are used to using. The only difference there is there's a layer 4 protocol that's different. So instead of TCP, there's a protocol called SCTP that has more availability features built into it for the signaling. And then on the user plane side, there's a tunneling protocol called GTP. But it's all IP that's moving across your MPLS backbone there. And then when you hit a core, that cellular core is just made up of various applications that are doing this. It all sits on Linux, and you're all used to Linux within your data centers. And it's just Linux containers in a modern core. And those applications run there. And that's all, that's kind of what it is. And I find when people kind of conceptualize this, it's a little bit easier to kind of think about it and then put the pieces together. Yes, there are differences, on the telco side, versus the enterprise side. But, at the end of the day, that's really what it is. And kind of just getting an understanding of that and an understanding of maybe some of the telco terms that do the same thing on the enterprise side. So like in the cyber world, we're used to standards like ISO, 27001 that dictate all of our cyber controls within our IT environment. Well, the telco world has the same thing. It's just called NESAS. It's a different term, but it's dictating the exact same things. So just kind of figuring out that, it's like, yeah, I'm used to this. I just need that term. Understanding the acronym, it gets a lot easier to just kind of digest this.
Thank you. Joel.
Sure. I when I was thinking about how to answer, I go to the operational side, just like you did, Emily. I mean, you do zero trust to create a secure environment to stop breaches, to stop attacks. But what was a surprise to me in the beginning is so you've identified your assets, you set rules about what they should do, and then something happens that you didn't expect. And it could be a security incident, it could be a breach, but it could be that a device fails and you need to dispatch somebody to go take a look at it. It could be a number of operational issues that need to be addressed. And those operational issues are much more tangible when you start to create an ROI about investing in some of this technology, whereas cyber still, despite everything we like to say, is still an insurance policy. So I think what's really interesting about embracing zero trust in your environment is, yes, it solves a security problem, and it's a requirement to build a secure environment, but it really does open up the world for addressing a lot of operational issues, which translate to cost savings for the utilities and their customers, and translates to them being able to deliver better services to their customers. So I think this operational aspect to zero trust is really sort of a good, refreshing way for utilities to look at it as well. And a free plug for OneLayer. If you come by our booth, we've got an ROI tool that we developed that really does look at the operational aspects of the network as well as the security aspects to try to create some ROI, some cost model that can show how investing in these technologies has a payback.
Thank you. And Jeff.
So I think two things pop out at me at first blush. So I think I'm talking to an enterprise security team. What I want to impress upon an initiative like Private LT is to say, one of the main drivers that a utility is doing this is to improve reliability standards, communication reliability standards out into the operations space. And so I think the first thing to recognize is that's one of them. There are other compelling financial reasons. One of the reliability components that utilities can do is physical infrastructure can be built in a more stout way. It can be built to the standard they want, whether it's the amount of backup generation facility they have to power a location, whatever the case may be. But one thing I think just as an industry to recognize, a private network in and of itself is no more secure or no more reliable than a carrier network, full stop, right? It's up to what the private enterprise does with the private infrastructure. And so I think this leads to your question is, what security is a main component. It's one of the main, I suppose, spindles on the stool of reliability. And so if you walk into a carrier infrastructure to see the level of security that goes into protecting the packet core and other key infrastructure, I think it's a lesson learned to that if you're building your own network, yes, it's private. Yes, the towers can have certain wind loading and generation backup and so forth. But there's a cybersecurity component to protect that private network that is so important to do because it's a direct correlation to the long-term reliability of that infrastructure. And so a lot of the conversations that we have sort of try to emphasize that. The LTE component, it's secure, it's reliable, it's the assets that are using to support that. How do we harden the edge of that closed system? So that's what I would bring in my security team to say, you've never had a packet core. I'll convey to you how important this is to our operations, because as we digitize and automate everything out in the grid, that digital foundation, that network, the reliability of that becomes directly correlated over time to the reliability of the grid. And so I would impress upon my security team those notions.
There's one observation, too, from all of the proposals that have come in and that we've processed. I would encourage everyone, you have an initial CapEx spend when you put one of these networks in. Do not forget the cybersecurity requirements in that initial proposal when you have that big pile of CapEx money. I'm noticing that some of those controls are being kind of set aside. It's looking at the network first, and that the utilities are having to go back to the money pile second round. So don't forget it on your first round. Life will go better.
And honestly, I was dancing around that issue. So yeah, when we see the designs and proposals come out, it has almost none of what I just mentioned. And so I don't know that it comes in later. And so whether it's the financial piece or better architecture, bringing that forward earlier is probably not a bad idea.
Truly the keys to the kingdom. So thank you so much. If you can join me in thanking our panelists for a really interesting and educational discussion on ZTE. So over to you, Bobby.